This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
Okay, so I'm sitting here at GoToCom with Fred George. He is in industry consulting and has been writing code for 46 years in over 70 languages. He's done quite a lot of different projects during his career in a lot of different countries like the States, India, China, and the UK. What he did is he started ThoughtWorks University in Bangalore in India with a commercial training program in the 90s. He has been one of the early adopters of object-oriented programming and Agile. And he still impacts the industry with pretty new ideas. So the last are about microservices and developer anarchy, and that is what this show will be about. So Fred, welcome to the show, and thanks for agreeing to do the show. So we are going to talk about developer anarchy. So can you describe what that actually is?
It's basically taking a team of programmers, sort of setting specific goals for what you're trying to accomplish at a business level, and frankly, just getting out of their way, turning them loose to go solve this problem.
I understand that you've successfully applied that at a company called Forward. So can you talk about what you did there, what the system does, and how developer anarchy fitted into the picture?
Yeah, I would say developer anarchy sort of came out of what we did at Forward. And this was kind of evolved based upon how we just wanted to run the business. So we were a relatively small group doing this work, a group of about 35 when I joined. And the net was we wanted to just try ideas out really quickly. We were doing Google advertising. This is kind of the Wild West days of internet advertising, so there are almost no rules. And so the ability to react to the particular situations you're in was very vital. And so it turned out that we began to value trying ideas out very quickly. And so anything that slowed ideas down, we stopped doing. So over time, we kind of lost the need for managers. We never developed the need for any sort of testers. We started deploying into production. And we started, frankly, making a lot of money. I think we had 1 year, we had 50 employees and made 50 million pounds. And that's a rarefied atmosphere. So it was working very nicely for us.
Who had those ideas or business requirements?
I think to some degree it evolved out of a very strange situation. We had a business area that was actually making quite a bit of money for us. And the managing director basically went to the manager of that area, the director of that area, and said, basically, you need some more programmers because you're making lots of money. And the head of the area, Carl, basically said, I don't know what to do with these programmers. If you give them to me, I can't tell them what to do. And he said, basically, take them anyway. And so he started making even more money. And so we had the same conversation again, take more programmers. And the guy says, I don't know what I'm going to do with them. And he says, take them anyway. He made even more money. What was happening was because the sort of the business owner didn't know what to tell them to do, he sort of described, well, it's about making money. This is how Google advertising works. And so the programmers started trying their own thing. And it turned out their idea generation started generating lots of different money. And so we sort of moved from the more traditional agile thinking of give me a story, prioritize stories for me, to these are the business metrics, make more money. And it turned out that actually worked really well. I was observing this at some level, participating part of that, but I was observing it, and I observed that a lot of the stuff I thought was core practices of Agile were falling away. We didn't have stories. We didn't have story prioritization meetings. We didn't do sizings of stories. We were just making money. And I came to realize that something magical was happening here, and I sort of captured why it was happening and little behaviors associated with it. And then I put a moniker on it called programmer anarchy or development anarchy.
So that is one of the things that I was wondering, is it programmer anarchy or is it developer anarchy?
I think it depends what side of the big pond you're on. In the US, we like to call it programmer anarchy. I think in Europe, we kind of like the word developer anarchy. But it really means the same thing. It basically means turning the programmers loose and getting out of their way.
So when you described that situation at Forward, it sounded like there were basically no people except for developers. Is that how the company worked?
I would say only about 25% of our people were developers. Most of them were doing internet marketing, which was our core business. And so they were interacting with customers, and the programmers were there to help build tools to help the analysts basically do a better job of internet marketing for our clients. So we're basically servicing ourselves in some level with tools. It just turned out that programmers, once they began to understand the business of Google advertising, got very creative in how they tend to do that.
So what made you start with Developer Anarchy, that specific situation? It seems like it basically just happened, or was there any real plan?
I think it was definitely an evolution of things. I think one of the things I began to realize is this was something special happening, something that looked very, very productive. It was almost the next generation of productivity I saw from going from a waterfall to an agile. It almost looked like the next step in that process, going faster. We were moving to the point where we started producing, putting new code in production every 4 or 5 minutes. And coming from an environment with IBM where we did every 6 months, something magical was happening. And so I kind of watched this and tried to understand it and replicate it to some degree with various other groups in our company.
Are there any success stories outside that company, or?
Well, yes, we basically took some of the same ideas and I've taken them to places like the Daily Mail. So the online version of the Daily Mail, the new version of that was developed with the same techniques. And then I did a startup in California. We used the same techniques there. So I've been trying to apply it in other environments. Going from a startup and making this work in a startup, okay, people can say, well, that's just a startup and we're very young and talented. Then you go to something that's like the Daily Mail, which is a 125-year-old company, and you make it work there, well, you have another endpoint here. It says, oh, by the way, it works in this environment as well.
Okay, so you're saying that it seems to be rather generic and not specific to one case.
Yeah, if anything, I would say it may be specific to particular classes of problems. Problems that, for instance, that you can get fast feedback on. So if I was going to build a probe to go to Mars, well, it's a little hard to keep testing that every 5 minutes and see if it actually gets to Mars. It takes a little while to get there. But if you're doing Google advertising where your feedback's within 20 minutes, or you're doing some any sort of day trading in financial markets, or recommendation engines, or internet sales where you get feedback very quickly, these sort of processes work really well. What you're really trying to do is to take the time from when you have an idea till you can try the idea out. You're trying to minimize that time. So it works really well in places where you kind of have the concept of let's try some ideas out. We're not sure what's going to work or not work, but how fast can we try them out?
So Anarchy is not the most business compatible name I can think of. What made you use that name?
Actually, I would say even within Forward, it was a bit controversial because it does have the negative connotations. If you look at the dictionary definition of anarchy, it means a group that organizes itself. It's not about everybody run off and do their own thing. It's about the group decides how they're going to organize internally rather than being given an organization from the outside. And that's the definition we use. But we also call it anarchy because, frankly, it's a controversial name. It gets a lot of publicity. And Forward was a company that was sitting in London, and we're competing for some of the best programmers with banks, which will pay an obscene amount of money. We're competing with Google. How do you find the best programmers in such an environment? You talk about very weird things that are going on in your company, and you give it a name that's like that. So I kind of stole the idea a bit from Kent Beck and this extreme programming. Back in the day when the first Agile process came out with extreme programming sounds like a pretty scary thing. I mean, programmers are already pretty scary. Extreme programmers, the visions you get with executives is not very positive. So basically, I said, well, that was a good idea. It gets a lot of publicity. It gets your name out there. And so we went with it.
It's interesting because I always thought that extreme programming was actually a bad naming, but I do see your point.
It was a bad name for trying to sell because I was trying to sell the services at the time and calling it extreme programming. It was very hard to sell, hence the name Agile, which kind of washes it all out, makes it kind of happy. We probably need to find the same thing for this. There are actually several now sort of managerless processes out there for software. I know one company in Michigan calls themselves an innovation center. They act the same way, but their idea is, you give us a problem, we'll come up with creative solutions for you. And so they have a better marketing term for themselves. But then in Michigan, you don't have to compete for programmers with Google. But it was definitely a market.
What are the cultural enablers? What kind of environment do you have concerning the culture to make that happen?
To some degree, besides the sort of the obvious one that you need a fast feedback on your environment. So it works in environments where you can try something and get results very quickly and judge whether you did something clever or not. Outside of that, you're moving up into a different trust relationship with your customer. It used to be, in most Agile processes, you're working at the story level. So he tells you what story needs to be done next because he sees the business value of the individual stories. He can prioritize it. We kind of want to move up a little higher than that. We want to actually interact with the feature level. Tell us what you're trying to accomplish. What are the KPIs associated with this? Teach me your domain. And so you have to have a customer sort of willing to sort of take that step and do that. And frankly, trust that you're going to do something productive with this money. Now, sort of the good news is you don't have to trust me very long because I start producing code so quickly and ideas so quickly that the level of trust doesn't have to reach more than a few weeks before you start seeing results. And once they see results streaming at them as fast as we can do it, trust is established and permanent. But you do have to sort of release some control over the environment when you say, I want to do programmer anarchy from a customer perspective.
But how is that different from Agile? Because at the end of the day, it sounds like the Agile processes where you also say, okay, I'm going to put out code into production as quickly as possible. And that way, well, it's the same principle where you get code out and then you see how good the Agile process works.
Well, I think to some degree it's that as well. I think we tend to actually deploy much more aggressively in Agile. It's not a matter of deploying once a week or every 2 weeks with iterations. We're talking about deploying each program deploying several times a day. And so the sort of traditional Agile processes which you have stories and iteration planning meetings and deciding what you're going to deliver the next, we don't have those planning horizons. Our planning horizons are measured in hours.
So it sounds like extreme Agile.
And I think that's kind of a nice name for it. I sometimes call it aggressive Agile, AA. Sometimes I would call it extreme Agile. But I think it's almost a natural evolution. It says if you think you're going fast now and you want to go faster, what sort of processes do you not need anymore? So the concept of a stand-up where you're going to figure out what you're going to do every day. Our planning horizon is shorter than that. Iterations are dead because we don't have a week. We don't work on anything for a week. We work on anything for a few hours and deploy something.
So much about Agile. I think I browsed through one of your slide decks and it said that you actually rewrote, or one of the developers, it seems, rewrote a microservice several times to get more insight about how the system really should work and to improve quality. Such a rewrite could make economic sense or not. How do you distinguish between those cases and why do you think the developer can do that?
I think it's one of these things that, again, it comes down to a level of trust. You certainly had, in the case in particular, we had rewritten a function that was sort of scattered in a .NET architecture across lots and lots of modules. We wrote it into a single Ruby module. They made it actually quite clear in the algorithm quite clear, and it worked fine. And then the team decided, well, there's this new thing called closure that may be a better fit for this sort of problem. Let's try that out. And they tried that out, and it was a little cleaner, but didn't do anything Ruby didn't do. Now I know more about closure. Let's try it again. Let's write it in better closure. Now it actually is doing things that the old system was supposed to do but never did. So it's still yet another improvement. And the question is, why would you let them do that? You have an entire rewrite to do, and they're doing the same thing 3 times. And my answer to that is, that's why you don't have managers. It is because we would not let them do that. It turned out we got some bad engine use. Bad engine use turns out to be really good for the business because that's when you make a lot of energy sales. The old system which we were using, basically started falling over under the load. We rerouted the traffic to this new code that was, tested, but not put under any load whatsoever. And this single module basically handled it all. In fact, at most it got to like a 30% utilization using the entire load that used to fall over, the old system fall over. So the code the programmers wrote turned out to be saved the day. We made tons of money that day because they had written such a clean implementation of a key part of the system. So when you sit back and say, from a management perspective, I've got to rewrite the system, I'm doing this one 3 times, why are you doing that? You got to trust the programmers that said, well, yeah, but it's not as good as it can be. It can be better. And it's worthwhile making that choice. They're making a great technology choice.
But it sounds like you were just lucky that your code really did make it that day and, therefore it became profitable. Isn't that just a lucky case and that's it?
It wasn't the only case of that happening. We basically wanted to play with Node.js when it came out. And we had, again, Ruby monitor of our internet sales. And we switched, and programmers switched after the Node because Node looks very cool. And we were like, no, it works. We're making a lot of money. This sounds like a very risky thing to do. They did it anyway. And it turned out it now ran on fewer servers, ran with lower latency. And it turns out lower latency was something Google was starting to measure. And we reduced our latency significantly. And it made a lot of money on that. Basically, just not being afraid to let the programmers go play with things if they think it can be better. Then we did play with a lot of other things that turned out not to be good ideas, but we figured that out very quickly. And to some degree, innovation occurs when you eliminate the rules and guidelines. And you turn these people who are saying solve problems in interesting new ways. And what are you going to learn from that? We would not have had this innovation if we had declared ourselves to be a Ruby-only shop or declared ourselves to use only certain architectural principles. The fact that we didn't have these rules is actually what led to the innovation.
So what would you respond to someone claiming that, technical people just want to play around with technologies and this doesn't make any sense and doesn't add any value?
I think to some degree that's because you're measuring the wrong things with your programmers. When you start measuring programmers on things like how many lines of code did you write, or how many stories did you finish, or how many story points, you're not really measuring the things that are important to the business. Programmers will play with whatever game you want to give us. Give us whatever metric you play, we'll play that game. It turned out when we gave them metrics like make money, or more or faster, faster Google response times, or higher Google rated ads, it turns out that's the game, they play that game. And it turns out they start innovating in that space.
So you're saying that they should play the right games and then it all adds up?
Yeah, to some degree, we were careful in our programmer recruitment. We basically are looking for programmers that are firstly self-learners, because we think the industry is evolving so quickly that if you're not a self-learner, you think you're going to be a Java programmer the rest of your career, we're not interested in you. If you call yourself a Java programmer, we're not interested in you. We want people that are programmers and think about themselves that way. So we want people that want to do things differently. In fact, we look for people who are, go to meetups, who participate in open source projects. These are the people you want to recruit. The second thing we look for is people who like to deliver. So, if you did something back in university and you got, a website up and you had like 100 people show up and you were very pleased about that, okay, that's not a success in any metric, but you're proud of it. You like delivery. You like trying things out in real. So when you have your feet grounded that way and doing something real and you have some metrics around you, I'm willing to turn you loose. I'm feeling that you'll be very successful in that environment. Now, one of the things we also let our teams do is you can be voted off the island. So this goes back to, survivor games. So if somebody's just not pulling their own weight, they're doing their own thing, they're writing their own languages, and I want to play with the other people, they get kicked off the team by that team. So part of programming anarchy is, yes, you can be voted off the island.
And how do you do that?
It's up to the team. It's the team to figure out how to do it. And so basically the team can say, we don't want this guy anymore.
And then it just happens.
It happens. And so basically that person will be taken off the team, just basically handed to somebody to handle the situation. But it's not part of the team's problem anymore. This guy wasn't working out with the team. It could be personality issues. Fine. We'll fix that. Could be a skill shortfall. Fine. Let's go fix that. It could be he just doesn't belong. He just doesn't care. So to some degree, there's these groups are also, it's anarchy, it's self-policing at some level.
So you're saying that even like these kinds of really hard decisions are still things that the developers decide by themselves?
Yes. You have to respect their decision on these points. Now again, once a problem's been identified and the person's taken off the team, then yeah, we'll go figure out what we should do with this situation. But I don't want the team to have to worry about, let's carry this guy some more, let's, all these other things, let's leave him in place, let's give him another chance. We don't want to go through that stuff. The team's decided this person's not very productive.
Okay, and then you have someone else deal with it.
Yeah, there was a Harvard Business Review article a few years ago that, the expression one bad apple spoils a bunch. There was a study which actually said how much does a bad employee influence other people. And it turns out he takes down 10 to 12 people with him.
Oh, really?
Yeah, it's really significant. It's a huge impact to the organization. And if you're working in a really close team and you're pairing, you're sitting around the same table, it's exacerbated. It's not like sitting in cubes. Somebody who's really disruptive is very disruptive to the entire team. And so you have to react to these situations extremely quickly. And that's why you set the principle up that says you can be voted off the island.
Everyone seems to agree that developer projects need some kind of management. Is there any management in developer anarchy left? Is there any management role?
There are a couple of roles that feel like management roles. I mean, if you look at what a manager really does as a project manager, you can sort of put a lot of different labels on it. And that's one of the exercises we often go through. So there's certainly the guy who's the mentor. It turns out managers actually don't make good mentors unless the people want to become managers themselves. A better mentor for you is probably the senior programmer on the team or the guy you want to be. There's certainly the concept of appraising your work and your contribution to the team. But the best way to do that in these teams is 360 reviews. Let the other team members say what your personal contribution is, because they know better. They work with you every day versus having some third party do that. There's certainly the role I would call ambassador. An ambassador is a guy who interfaces to the outside world. But I like the idea of an ambassador because ambassadors don't make decisions for the countries. They represent the interests of the countries. So you send somebody out there in your team to talk to another team, he's the ambassador. He's carrying your opinion there. He comes back and tells you what they think, and you come up with solutions accordingly. So there's certainly that role. And there's certainly the role I might call concierge. The guy who gets you your LAN adapters, goes to get you another resource, the guy who may handle this extra personnel issue you have, you kick somebody off the team. But he's a concierge. He works for the team.
I guess the senior developer would still write code. What about the concierge and the ambassador? Would they also still write code?
I like these members. I like these people to basically be members of the team as well. And the team sort of decides who the leader is. It's not to say the senior guy, the oldest guy in the member. It's because to some degree, the leadership of the team should morph based upon the project. Early in a project, you want the guy that's sort of in charge is the guy that has a better architectural background, understands the big picture issues, knows how this is a front end, back end deployment sort of issues. Gets to the end of the project, it's about operational issues come to the forefront. You want the guy with the best operational experience and who really cares about all those minutiae. He should be the guy in charge. And you want that sort of leadership role to morph. So we don't go in there and anoint a team lead, but we're a social organization. We will tend to pick our own leaders.
So that would be the senior role. What about the ambassador and the concierge?
Well, the ambassador tends to have an ability to communicate and understand other people's opinions. And certainly you want somebody in your team that's able to do that. You probably want several people like that. And you also have the ability to sort of give that role to somebody who wants to try it out and see if he likes doing that stuff and see if he's good at it.
So he's probably still a programmer and still writing code most of the time.
You still want those guys as programmers and writing code. The only guy that may not be a member, may have a full-time role outside the team based upon the team sizes, may be the concierge. You could be the concierge for lots of different teams, whether it's getting them LAN adapters or a database expert or picking up these people that get shuffled off the team. That tends to be more of an outside role.
If I'm a manager right now, like a project manager or one of those non-coding architects, would I be out of a job if we start developer anarchy?
What we did at the Daily Mail is we basically took people who had those sort of roles and we trained them back as programmers. We gave them an opportunity to learn how to write code in a modern language, Ruby in this case. First of all, if you're a former manager, you have great people skills. And you probably at one point were a programmer, had a technical career at some point. If that's the case, I'd like to have you in the team because you'll see these personnel issues from the inside of a team. You may not be the best programmer on that team as you get retrained, but you're a contributing programmer. But you'll certainly see these personnel issues. You'll see that this is a people issue, not a technical issue, not a process issue. You'll be able to see those things so well. So I'd like to do that. Same thing with architects. You have great conceptual skills. That's hard to train somebody in. I need those conceptual skills because I'm giving you a feature to implement, some big feature. You need to figure out how to solve that. Architecture is very important to that. But you need to understand how to do that with modern languages. So training you back as a programmer seems to be our first choice.
How did that work out? I mean, did people enjoy that, or were they more like, okay, I left that part of my career and I'm now at a higher level, so why would I step back and do that again?
I think in the majority of cases, the managers who went through this stuff turned out to be very good programmers, but still chose to stay in a management career. So they would tend to leave the organization and go somewhere else.
So you're saying that most of the managers actually left?
I would say a majority of the managers left. A few turned into concierge because that was their natural, they were very good managers to start with, and the concierge model is very much how a good project manager should work. And so some of them moved into that role, but there weren't a lot of those roles. Architects tended to stay as programmers. In fact, one of the things that would happen is as people were leaving, and especially managers were leaving, we backfilled with architects who still wanted to write code. And their current companies did not let them write code because they're architects.
That means that probably a few people actually left the company and quit the job. So was that something that caused a bad name for the whole project?
I think actually probably more than a few left. I would say, we may have had 20, 25, or 30% of the people leave over the first 6 or 8 months at the Daily Mail. And we backfilled them with talent that dwarfed them. What happened was once people figured out we were working in this sort of process, it's very, full stack developers are valued, programmers are first class citizens. We had people quitting other jobs, taking pay cuts to come work with us or commuting extra hour into London just to come work in this environment.
To be quite honest, that sounds like as a manager, I shouldn't start doing that thing, right?
I think if you're a manager interested in having continue your management career, yes, you don't want to start this thing. I think this is the sort of initiative you'll see that sort of starts from top down. This is one of those things that you'll see at a C-level executive, whether it's a CTO or CIO or some VP of development, say, I need to be more responsive to my customers. I need this sort of stuff. I need to change the interaction style among my business users.
So would you sell it at the C-level, or how does it work?
Basically, you sell at the C-level. If you go to the C-level people and tell them, we're going to make a social change to your organization, it's going to have the following impacts for the following reasons. They understand it. And their reaction is typically, I've been trying to do this for years, and I keep getting all these roadblocks. You've given me a way to make this happen. Let's go make this happen.
I mean, my impression is if you try to do an organizational change and this social change from the C-level, it's often very hard because people are reluctant to actually do it. So is that an issue?
I call it the sandwich strategy because it's pretty easy to get the C-level guys excited by this. It also turns out to be very easy to get the developers excited by this. I mean, developers don't want to come in and go to meetings all day. They get to write code, deploy code. They don't have to go through operational dances and stuff like this. They want to go into the cloud. They want to use modern languages. So you get the grassroots are happy about this, and the C-level are happy about that. And the guys in the middle are risk averse, and you just need to squeeze them. What you want to do is create the environment when that web services compliance architect who's sitting in his ivory tower runs up to the CEO and says, "Oh my goodness, these guys are doing these crazy things. It's all against our principles." You want him to say at the C-level, say, "Yes, I know they're doing it, and I want them to keep doing it." And if he's really risk averse, he's going to start figuring out how to support this environment, or he's going to look for a new job.
But if you have that kind of responsibility for developers, I mean, apart from being great developers, they also need to be great architects and great requirements engineers. So, I mean, basically they are doing all that stuff by themselves. And it's already quite hard with, all these deployment technologies and things like that. So isn't that asking for the impossible for developers to be like superheroes that can do everything?
It's not that any individual develops a superhero, but the team overall is a superhero, is working as a group. So it's not everybody needs to learn every language and every technique. You need to have a couple of people in your team that understand deployment at some level. You need a couple of people that understand architecture at some level. Some people that understand user interface and user interaction at some level. You want a few people in your team that have these skills, and the team will recognize who those people are.
And then they just figure it out, and then you still might have people that care about specific problems. And
yeah, you certainly have people that are going to be better at certain things than others and have certainly interest in doing that, and you support that. The thing you want to watch out for, and the team will be very vocal about this, and this, again, role of the concierge, you may be missing a skill. You may not have a front-end engineer who really understands UI, but the team will recognize that and say, we need that sort of skill. And part of the job of the concierge is let's get that person, add that to the team. And teams work very closely together. Pair programming works very well in that environment. You want that knowledge to float around to the team, so everybody becomes a little more competent at what they're doing.
If I look at traditional organizations, I mean, oftentimes the kind of money you're making is actually depending on your job title and what you're doing. How do you deal with that? If you ask me as an architect to step down to become a developer again, it probably means that I make less money at the end of the day.
And that's one of the things we changed at the Daily Mail. We actually defined new job titles that were based upon levels of skills of responsibility. So if you were competent in one of our core technologies, we called you a developer, and we had to pay scales associated with that. If you were an expert in one of our technologies, we called you an expert. We paid you handsomely for that. But we also paid you handsomely if you were skilled, competent in 5 to 7 of our key technologies. In other words, you were really truly poly-skilled. We valued you because you were the sort of guy I can hand a problem to, and you know how to decompose it. And we thought that was a very valuable skill to have. And we paid you the same as we pay an expert. And then we had these uber experts who were basically masters at more than things. And we had another pay scale for that. And that was our pay scales. And so now you're motivated not to become a manager or an architect, but in fact to have better skills that were aligned with the technologies of the business.
So it's a true career path as a technical guy, basically.
Yes, and progressive companies always had a career path for technical guys. I mean, IBM had a very nice one when I worked for them. But sometimes a lot of companies just pay lip service to it. You still get more prestige being called something else. And so we flattened that out. We basically eliminated that. So we killed titles associated with team lead. We killed titles associated with any sort of management. We killed all those titles and replaced them with competence titles: developer, senior developer, system developer, master developer.
Do you think developer anarchy is an agile approach?
I definitely think it's agile because it sort of fits all the sort of principles behind agile. We love communication. We love simplicity. We love feedback. We like to respect each other. So the core values and core principles behind it are the same. What winds up being different is some of the practices. Because we're interacting with the customer at higher than a story level, a lot of things don't align. So the iterations kind of fall apart when you're deploying twice a day. Stand-ups don't really have a meeting in that environment. Retrospectives, where you come up every few weeks and get together and decide you're going to try something different. We would try something different immediately. There's nobody telling us we can't do it. And so we were basically trying new ideas out continuously rather than waiting for some retrospective to put some ideas on the table.
What about those, let's say, more developer-oriented things that you have in extreme programming, like, pair programming and unit testing and refactoring and these kinds of things?
A lot of these things actually changed it forward because we went into a microservice architecture, which sort of gets us into a whole different discussion. But a lot of the techniques associated with agile programming, like refactoring and unit tests, are what you do in order to wrestle a large code base, a large monolithic code base. These are things that keep that code base sane, so you can keep making changes to it continuously. When you start writing small pieces of code, 100 lines of code or less, these practices don't make any sense. And what we found out was, we stopped doing some of these things and didn't miss them when we started doing microservices. So to some degree, microservices was driving some of these process changes as well.
Do you think that you can only do developer anarchy if you do microservices?
I think developer anarchy is key. The most important key is to make sure you have fast feedback from whatever you're doing so you can try it out. I think that's the thing that sort of makes it work. I think once you get into fast deployment, I think programming anarchy is a natural evolution of where everybody's going to be. If you go to rapid deployment, where rapid deployment means deploying several times a day at least, I think you move into much more what looks like programmer anarchy than what we have now. Because I don't have time to engage a QA group or have a hand-holding session with a customer and do story prioritizations, to story estimating. I'm doing things so quickly that these sort of steps don't make sense anymore.
So what you're saying is that if I use microservices, I will do developer anarchy at one point?
If you do microservices and you're interested in deploying them very rapidly, you will probably move naturally into a more of a programmer anarchy situation, a much more managerless process.
And the other way around? So, I mean, could I do developer anarchy without microservices?
You definitely can do that. The thing about is deployment becomes problematic if you have to, if you can't deploy fast. So if I can't really deploy quickly and get real customer feedback. So if I was doing, for example, building a Mars probe, and it's going to take 3 years to get to Mars with this probe, I'm not going to be able to basically just continuously deploy new changes to a Mars probe and judge the reaction of that. I'd probably need to put some sort of acceptance test in place or some sort of way to test the system to see if it still works. So one of the things we realized with developer anarchy was unit testing and acceptance testing are feedback processes that you need if in fact you have not got a natural feedback process by deployment. So you can deploy and judge whether it's successful or not that way, we'd rather do that. But if I can't do that, I will fall back on these other practices.
So are you saying that you should sort of test your code in production?
Actually, we would basically go from notebook to production. And the reason we were safely do that is we had instrumented our systems to such that if we deployed something in error, we would find out about it almost instantly, and we'd roll it back.
There is certainly a risk to that, right? I mean, if you deploy a bad piece of software and it's a sensitive system, then you might lose a lot of money in doing so.
Yeah, in fact, we would lose $300 profit a minute if we do something wrong. And so we still did that because it turns out that getting it out there quicker makes more than $300 a minute. And so always treat it as a cost trade-off. If it costs as much to make an error, how often do you make these errors? Do the arithmetic. If the process to prevent you making errors is very expensive and it only costs you $300 a minute and you find things within 5 minutes, you can do the arithmetic. Is it a good idea or not a good idea?
Would you think that those $300 a minute, is that like if it's higher, then you shouldn't be doing this?
I think it depends upon which system you're trying to, what your metrics are. But in our environment, we're doing Google advertising at the time. Being out there with a better ad and a better algorithm to find a better ad was making us thousands and thousands of dollars a day. Even we were spending sometimes over $1 million a week in Google ads at a few cents a piece. So we're doing massive amount of advertising and tweaking those algorithms a little bit. It's just profit to the bottom line. So we are more than willing to tweak very quickly these things and try to make a little more money, even at the cost of occasionally having a $300 loss.
Okay, so what you're saying is that it depends on how much you value agility at the end of the day.
Yeah, how much do you value time to market?
Concerning microservices, I think you're also an expert in that field. So I believe that you advocate pretty small microservices. So how large should microservices be in your opinion?
Well, let me start by saying we tend to solve specific problems with our microservices. I would say we tend to work on fuzzy problems. Fuzzy meaning there's not a clear answer, expert answer about what the right answer is. And this is like Google advertising, day trading, even things like recommendation engines about what book you want to read or should I loan you money. So these are the sort of problems we are wrestling with. These sort of problems are problems that trying ideas out becomes very valuable. How many ideas can you try out? How fast can you try these ideas out becomes competitive advantage. That's where microservices comes from. And so the style of microservices we have that I talk about, they tend to be very, very small. They're single function services. They do one thing and one thing only. And I want to try out different ways of doing that. I want to try out different algorithms very aggressively in that environment. And so that style of microservices, the ones I talk about, tend to solve these fuzzy problems. If your problem is I need to create a bank statement that's absolutely perfect, this style of microservices doesn't provide you any competitive advantage. I might provide different style of services.
So what you're saying is that I get very fine-grained microservices, and that way I can easily switch small parts of the system.
Yeah, the smaller the service is and the less coupling it has to the rest of the system, the faster I can try changes. In fact, I want to have 2 or 3 versions of the same service out there simultaneously compete with each other. I want to be able to try these ideas out aggressively.
I mean, lines of code is of course a small metric, but we are talking about more like 10 lines, I guess, than 100.
Yeah, well, we're talking about probably less than 100. If 100 lines, if I'm probably using a language like a Java or a C#, it's probably less than 100 lines of code for most services. If I'm talking about JavaScript, I'm probably talking about 15, 20 is all I need. Every service should be doing something, should be drawing some conclusion, but that's all it does.
How many microservices are there in such a system then?
I think at Forward, we got to the point where we had over 300 microservices running this way. I know if you look at the microservices associated with Netflix, which is a somewhat different architecture, they have about 800 services running. I'm seeing numbers from various people in microservices where everybody's getting up to well over 100 to 200 services at least.
So it's about 300 microservices at about 100 lines each. That's roughly what you're saying.
Yeah, although we do have some supporting libraries we've written. We wrote, so for example, we did a lot of Google reporting, pull reports off of Google, so we wrote a library to do that for us. It was a more complex piece of code. We did write unit tests for that because we don't have the fast feedback otherwise. But that sort of thing helps to keep the services small if you write utilities like that.
That sounds like a rather small system. So do you think that there is a limit concerning the size of the system for these kinds of architecture and also for developer anarchy?
Again, we're pretty new in this space, so it's hard to say. But certainly Netflix is much larger than that. I mean, Netflix is 600 or 800 services. Their services tend to be 1,000 or 2,000 lines of Java code. So the services themselves make up a pretty big body of work. Still less than probably 1 million lines of code. But then they have some very, very interesting frameworks they've developed to support this, these sort of services. It's almost like the services themselves are becoming scripts, and we treat them that way. And we use, and we build libraries around to make these scripts and keep these scripts very small.
Oh, I see. Why are you using the term script for that?
Because the logic is pretty close to what you'd see in a scripting language. Pulling in some inputs, make 1 or 2 decisions, generate some outputs. And you can probably use any language that sort of allows you to do that. So it could be, it could be Java, it could be JavaScript, it could be PHP, anything that sort of lets you sort of do that stuff. Language is not terribly important. It's sort of the architecture of the overall system, the very small services, the single functionality.
So you would advocate a model where basically every microservice might be written in a different language?
We don't mind that. In fact, we exploited that quite readily at Forward. We would use Ruby for things that interact with the front end. We would use Clojure for doing heavy lifting if we had some really heavy calculations. Traffic monitoring we do with Node.js. Analysis of KPIs we sometimes do with R. We were able to use sort of the right language for the right situation. By the way, programmers kind of like that. They like to be able to try a new language and try new functionality. They learn something new.
So how do the microservices actually talk to one another, like synchronously or asynchronously?
Both models exist out there. Netflix certainly errs on the side of synchronous models, and they built a lot of frameworks to allow them to try A/B testing and all sorts of things in that environment. I tend to be a fan of bus-based systems where the services don't really know about each other. They're just publishing events on a bus and listening for other events that are related to those. And so by a chain of services sort of triggered by a series of events, you accomplish work. I like the asynchronous model because it's very decoupled. I don't know what service is listening, and I can put 2 versions out there very easily and not have that problem. The challenge with asynchronous services tends to be is not how programmers think. Programmers, things have been described to us as here's step 1, here's step 2, here's step 3, and we tend to implement the flow very synchronously that way. And a lot of people start with microservices, building services along those boundaries and do RESTful calls. But you still kind of have this chain of events. And if one of these things breaks, then your chain breaks. Asynchronous is a different way of thinking about a problem. Can I do step 1 and 2 in parallel? Can I do step 1, 2, and 3 in parallel? And then sort of accumulate the answer. If I think about the problem differently, I come up with a sort of a different architecture for that. And to some degree, that's what asynchronous leverages.
Would you still somehow try to keep track of all the microservices there are? Because at the end of the day, as a whole, they form the system, and it might be of interest what the system actually looks like.
Well, there's sort of 2 questions there. One is, I'm trying to write a microservice. Is there one out there already that I can use? It turns out we didn't worry about that problem too much. It turns out that if you're spending time writing and documenting these services and putting them in some sort of repository and being able to search that repository, it takes a lot of time to sort of generate and keep that documentation up to date. And what are you trying to save? I'm trying to save you 2 hours writing a new service. So if I look for a service, I can ask my table people, colleague, some guys that do something like this, and everybody says, no, I don't know anything that does that. Write it yourself. If it happens to be the same as another service, it took 2 hours to write it. What's the big deal? So again, you have this trade-off of, I want to make sure I have only one service that does one thing, or it's only 2 hours. How much is this costing you? And we erred on the side of a service being easy to write, and we just write it again. Maybe one day we'll recognize we have two that are running the same way, and we'll get rid of one.
One of the obvious questions that I always get asked when I say something like that is, what about fixing bugs? Because obviously you need to fix bugs in two different points in your system then. So how do you deal with that?
We should fix the bugs in two places. It turns out to be in two places. That's probably the day you discover it's done in two places. Is when that happens. One of the interesting things is we may have services that are not being used anymore.
If you look at an architect is supposed to, or the architecture, it's supposed to talk about the parts and how they talk to one another. So do you think that this level of understanding of a system is not needed anymore in a microservices system?
I think that level of understanding is needed, but needs to be embedded within the team itself. So it doesn't have to be exactly one person, but the team certainly understands how their system works and how it interacts. That knowledge exists at the team level.
So would you say that there should be one guy who actually understands the system, or?
I think in practice it turns out more than one guy understands what the system looks like and how it works. In fact, most of the people sitting at that table can describe the system and how it works. Now, I think it probably takes an architect to come up with that design originally. In other words, how do I break this problem down into a series of asynchronous microservices? That's conceptual skills. That's a good architect.
So everyone on the team would understand those 300 microservices and how they work with one another?
Most of these were broken up among teams. So we had 50 programmers at that point in time with 300 microservices. So a team of 5 programmers probably had 40, 50, 60 services they were responsible for. And they understood basically the role of those 40 or 60 services.
At the end of the day, that means that nobody understands all of those 300 microservices and how they interact with one another.
No, but you bring 3 or 4 people together, you probably would get that knowledge if you needed it. But we're not necessarily trying to share across that. I mean, typically, and say one of the applications we were doing for a startup was an offer engine. So we were basically deciding additional ads we want to put on pages if you're renting a car, for example. And it turned out we had to write about 15 to 20 microservices for that. And so, yes, everybody on the team understood what the 15 or 20 microservices were and how they interacted with each other, what role they played. And if you're kind of new to the team, you just kind of ask somebody you're sitting with, and we pair up for that sort of stuff as we need to.
If you have a microservice, I think it comes with a cost. You need to deploy it, you need to monitor it, you need to do something with the log files. How do you handle that if you have this number of microservices that are so small? It seems like quite an expensive price to pay for that little amount of code.
Well, let's sort of talk about each one of those in turn. From a log perspective, logs are events. And so every time you want to log something, you've done something interesting, you want to log it, we basically make that an event, we put it on the bus, the event bus, in asynchronous. So it's just another message on the bus. And we kind of like that philosophy because that means the event bus has not only the messages that are flowing back and forth, but it has all the logs associated with it, and traffic stats and other things. So if something goes wrong, I have a complete stream of events that includes the logs of indicating things are going wrong, along with the services and the message that probably caused it. It's all sitting in together in a stream. Very easy to debug. And logging like that is very easy to do from a service. You just publish another message to the same bus you're on. In terms of sort of some of the other aspects you were asking about?
Monitoring and deployment.
Basically, every service that we deploy actually announces itself on the bus when it comes up. It heartbeats on the bus, and when it goes down, it announces to the bus, I'm going away. We write other microservices that watch for that. But there's just more events on the bus, more microservices to do the monitoring. So the monitoring is kind of built into the asynchronous architecture. Now, if you're using a synchronous architecture like Netflix, they built all sorts of frameworks to handle these things for you. And so lots of helper frameworks are available to build that stuff. But there are over 40 different open source projects out of Netflix to help address the myriad of issues they addressed.
Okay, and what about deployment? I mean, you somehow need to run that code on some machine, and you need to provision that machine.
And to some degree, that's why the clouds kind of enabled us, because the clouds provided us easy deployment environments. We're getting down to the point where we understand that one-click deployment is what you want to have. If you need additional capacity or bandwidth available with a service, we know how to deploy those in sort of dynamically as we need based upon additional triggers. Again, the cloud gives us those sort of triggers. So to some degree, we pushed a lot of our operational issues back into the cloud and say we want to exploit the cloud for this. And we still need some expertise on your team that says, I understand these things exist, I understand how to exploit them.
And what about the cost of operations? I mean, then you run quite a few servers on the cloud, I guess.
Yes, and to some degree, the operational cost of a service that's not doing very much work, at one point in time, we calculate that as costing us $40 a month. It's dwarfed by programmer cost and the money we were making. So it just turned out to be a cost we weren't going to calculate. Now, if you're Netflix and you're taking up 20% of all Amazon cycles, you optimize a little bit more around that. But for most environments, we don't realize just how inexpensive a virtual machine is, particularly one that has very light load.
If you build a distributed system like that, it seems to be heavily distributed. What about performance? I mean, obviously there is the first law of distributed objects that says you shouldn't distribute your objects, and I guess for very good reasons.
Well, performance is one of those trade-offs you want to make against time to market. And again, most of the environments we worked in, especially for fuzzy problems, time to market is key. You know, the amount of time it takes from trying an idea out to see if it's good or not. The amount of cost associated with that outweighs a lot of these other costs, if I get it right or wrong. And because of that, we tend not to worry about that deployment cost. We're certainly willing to burn lots of cycles of CPUs. We're certainly willing to burn lots of bandwidth of messages. I mean, running the backplane of some of these boxes right now is a 30 gigabit backplane between the various services. The latency is almost in the nanosecond range. So when people say, I want to optimize to make sure I'm not too slow or burning too many cycles, I think you're probably optimizing the wrong thing. It's kind of like pre-optimizing your SQL program. If somebody told you, I need the really fast SQL database, well, the right design is one table, lots of columns. Nobody starts there. Everybody starts with a normalized SQL database, and then you denormalize as you need to get the performance at the right spot. You want to treat your microservices the same way. You want to start out with a normalized version. They do one thing only. But if you find a point in time where doing 2 things or 3 things in this microservice significantly saves you lots of money and speed, denormalize it at that point. But don't start out with a denormalized design. Don't start out with an optimized design.
So actually you would start off with a myriad of microservices, like small microservices?
Yes, because getting the architecture right and getting and reacting in time to market is probably the most important part of getting your system correct, especially for the fuzzy problems. If somebody could describe exactly how a system should work, like this is accounting practices, this is what a balance sheet should look like, I can design a more traditional system around that. If somebody says, should I loan you money or not? They can't describe exactly the algorithms that are going to figure that out.
If you split a system apart into multiple microservices, on the level of the architecture of how the system is split apart into microservices, it's hard to change afterwards, right? So isn't that a problem? Because if you want to evolve the architecture on that level, then you're limited?
It hasn't been so far. Not if every microservice kind of has the philosophy that says, I'm going to read some information, make some decisions, and publish my decision. And if my decisions are very, very small, it's easy to rearrange these things and inject new people in to help make different decisions. So in practice, we have not run across this problem. I think the architectural principle that we follow it's very much like this Unix philosophy that every little command needs to do one thing, and I will chain them together to accomplish more important things. That's sort of the philosophy we take with the microservices. We're going to chain them together to accomplish interesting things.
Do you think that this is just because that your problems can be split apart in that way, or do you think that it's generally applicable to all kinds of problems? Can all kinds of problems be attacked in this manner?
I would say at this point, in the world of microservices, we're inexperienced. We're just scratching the surface of what the best. We haven't got even a best practice patterns book yet. We don't have a lot of architectural frameworks. We're very new at this stuff. I would say in my limited experience, and I have about as much as most people have, a lot of these problems just haven't arisen for us. We have been able to solve our problems. Now, that being said, I tend to work in the fuzzy problems. That tends to be the sort of problems I get excited by. I'm not building payroll systems. I don't build accounting systems. I build fuzzy systems. And this has served me extremely well in all the environments I've been in.
Yeah, because obviously, I mean, as you said, if you look at Netflix as the different microservices architecture that a lot of people speak about, it's actually very different, right? I mean, because the larger services, they are synchronous, and it's a completely different idea.
Yeah, if you look at Netflix, it's like I'm picking a movie, I want to see a movie, I want to see a TV show. That part is structured completely differently, and it needs to be very reliable. You need to start playing your movie. And if it does stop, you want to be able to hit play and resume where you left off. So that part is somewhat a different problem. When they start deciding what movie you like based upon this movie, then they do have a little bit of recommendation engine, and I think they actually implement that somewhat differently.
How do you start with developer anarchy? So if I want to make that happen, how do I do that in my environment?
I think one of the things you have to do is look at what your inhibitors to starting that sort of process is. And make sure, by the way, I'm trying to do it for the right reasons. Probably want to do this, go to developer anarchy because I want to solve problems quickly. I want to try ideas out, sort of, again, these fuzzy problems. Then you want to figure out what the organizational inhibitors are. What's keeping you from deploying quickly? What's keeping you from doing that? And so you need to sort of think about what organizational changes you need to make. What's the role going to be for the customer? The customer now is going to be, his job is educating the developers on the business domain versus telling them what story to play next. So you need to sort of rework that aspect of it. You need to go tackle the operations issues. How are you going to do the operations now that we're going to deploy into a cloud? And to some degree, even before I start programming Anarchy, I may want to go fix some of those issues.
Before at the show, you said that you need to have buy-in at the C-level. So can I even start that kind of process if I'm just a developer?
I would say I've been unsuccessful doing that in that role. I was even unsuccessful in having sustainable agile projects in companies without the C-level backing. Eventually you walk out the door when you finish the project and all of a sudden a lot of the agile stuff you're doing goes away because there's so much resistance from middle management. You need to have the C-level guys lined up behind it because to some degree we're making a social change.
What you said is that at least for agile projects, if you go there and you do it, it works as long as you stay there. But do you think that's possible for developer Anarchy at all?
I think that's what you have to do as well. What you have to do with Agile is what you have to do with developer Anarchy. You got to get the C-level buy-in. You have to start it working at a fairly low level within the group. And then you can sort of begin to back off of that and let it be self-sustaining.
What else can I learn from developer Anarchy even if I don't start with it and I can't do it full-fledged?
I think there are certain things you want to sort of do to get ready for developer Anarchy, and one would be let's fix your deployment process. You know, who's allowed to make deployments and what's stopping me from doing quick deployments? You can tackle that issue. The other thing you need to do is probably wrestle with the database. A lot of enterprises have an operational SQL database. That's going to be an inhibitor to fast deployment. So one of the things you have to do is go tackle that database and blow it apart.
So what do you mean? Do you mean that you would separate it into different schemas, or would you replace it by a NoSQL database?
A little bit of both. To some degree, the operational SQL database is replaced by the event bus in my world. So the persistent event bus holds all the information that is also in the operational store. And then each of my microservices will have whatever it needs in order to do its job. So if it needs a key value store, maybe that's all it needs.
So you would actually provide one store for each microservice if you want to do that.
And Chad Fowler talked about this this year at the Microservice Exchange Conference for what he did as Wunderkinder. And the first thing he did was he blew the database apart. He made it lots and lots of smaller schemas. And now he had the smaller schemas, now he can start developing the smaller services around each of the schemas and break the services up. But the thing that was killing them was a gigantic database that the queries were running very poorly on and the project was failing and the system was turning over. And that's what he had to attack first.
So would you do it again? Is developer Anarchy something that you would do again?
It's probably the only thing I would keep doing, and unless something comes along that's even brutally faster. But I kind of think that's the approach I want to take on all projects at this point. I think the motivation of the people is just enormous. I mean, we like it. I mean, programmers come in every day, and we don't come in every day and say, let's write some bugs, or let's go to some meetings. We want to come in there and write some code and deploy it. So we're creating an environment that's extremely positive and motivating for the developers themselves, and they have fun. And you're also setting up a reward system where they get rewarded for having good programming skills, and they can continue to grow in that role. So yeah, I like all those aspects. That's the environment I want to work in. If somebody offers me a role and I can't work in that environment, I think I walk away because it's not fun.
How do you see the idea spreading right now? I mean, is it catching on? Are there a lot of people jumping on it?
I do see it. Now, it comes under several different monikers at this point. So it's like, was an innovation center. I heard a presentation at one of the other conferences. Somebody else had another name for it. There are lots of names for this sort of managerless process. And I'm certainly not waiting to program Anarchy. I'm waiting for the group to get together and come up with a new name for their agile version of what the name's going to be, some positive version of it. But I think the managerless processes are here to stay. And by the way, they've been here quite a while. If you look at any bank does day trading, they're running Anarchy. The day traders are sitting right beside the traders, and they're making changes to the system. They don't care what standards they are. They don't care what the CIO says. They're working for the traders. So that environment has actually been in place for years. It's really kind of funny to listen to the CIOs complain about, oh, these guys aren't following my standards. They're not doing deployment the way they're not following any of the rules, and the programmers keep doing it. Because who pays their bonuses? The trader. And there's the business case.
Okay, anything else you want to add? Anything else you want to say?
Just that as you get into microservices and managerless processes, talk about it. I mean, there's growing information out there, but we're still in the novice area of the stuff. The more you share, the fewer mistakes other people are going to make. So even if it's not successful, come please talk about it to the rest of the world. We're very curious. And the nice thing is there are great conferences associated with a lot of these topics that we can come to.
Okay, thanks a lot. Thanks a lot for discussing it with me and for being on the show. I enjoyed it a lot. And yeah, I hope you have a great conference here.
Well, thank you. And I certainly enjoy talking about this, as you can tell. So, and good luck to the audience.
Okay, thanks a lot.
Thank you.
Bye.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can write comments on each episode on the website or write a review on iTunes. Mention or message us on Twitter at SE Radio, or search for the Software Engineering Radio Group on LinkedIn, Google+, or Facebook. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Thanks again for your support.